If you've ever been through college, you might associate math with calculus, or superior mathematics, as it's called in some parts of the world. Fundamental notions such as continuity and derivatives give me nightmares even to this day, so if you feel the same way, welcome aboard. Oh, almost forgot. If this is our first time meeting, I'm Alexandru, the CEO of Collabos, and I'm excited to take you on this beginner discrete math journey. Calculus was invented in the 17th century by Isaac Newton and Gottfried Wilhelm Leibniz at the same time. The funny part is, neither of them knew about each other's work, and since then it overtook mathematics as the most influential field. Calculus gave birth to modern math and paved the way to applying mathematical concepts to sciences. Even though it's so important, calculus is super technical. The fundamental notions of continuity and derivatives needed 2 centuries just to find a proper way to describe them, so no wonder I still have bad dreams about them. We're looking at years of study if you really want to feel the power of how calculus excels at describing exactly what it was created for. Don't be discouraged by what I'm going to say next, but if you want to become a mathematician, computer scientist, or engineer, this investment in mastering calculus is very important. Software engineers, on the other hand, don't always need this type of knowledge, but instead have to focus on other branches of math. Calculus is not the only hot topic in applied mathematics. Recently, and I really mean a few decades, a branch called mathematical cryptography has started taking off. It's based on number theory, which is the study of positive integers, whole numbers such as 1, 2, 3, 5,000, and so on. This new branch is heavily used in computer security and electronic banking. It's thanks to some basic math principles that we're able to purchase things with debit and credit cards, protect our personal data, encrypt sensitive information while allowing the right people to access what belongs to them. Linear programming, coding theory, and theory of computing are some other branches of applied math, and these, together with mathematical cryptography, make up Discrete Mathematics, which is just a fancy way of describing that they deal with finite sets of numbers as opposed to infinite or continuous, like in calculus. Covering discrete mathematics in depth here would be impossible and impractical, so this is not the aim of this course. Our goal is to get you familiar with combinatorics, graph theory, and combinatorial geometry sprinkled with a little bit of number theory. Since math is based on reason, proving why you think something is correct comes with the territory. If I claim something incredulous without showing proof, it can't be taken seriously, so it's similar when it comes to stating facts in math. Personal feelings aside, when refusing to show proof, the others don't have any idea about why what you claim is true, and have to perform the same work you did instead of simply transferring your knowledge in no time. This is why, whenever possible, we will show proof of the concepts we talk about, so that you'll understand why they are true. And yes, there are some situations where it's so difficult to prove a concept. This refers even to some elementary facts that we've all come to accept for a long time, that we'd need to go through more advanced courses first before we can reason about them. But in those cases, I will mention this limitation since breaking it down goes beyond the scope of this course. All this talk is in vain if we ignore one more important ingredient of math: problem solving. This is not related specifically to math, so getting in the habit of finding solutions to problems is a universal skill that is helpful in pretty much all areas. You won't learn math by watching these videos unless you get your hands dirty by trying out the ideas you discover here in the exercises that come with this course. Don't let it scare you, because solving problems is a native ability for us humans. Otherwise, our species would have died a long time ago. Most of us pursue this type of problem-solving activity when playing chess or putting a puzzle together, which are good examples of discrete mathematical problems. Just treat the exercises in this course as puzzle solving, and if you end up using an idea you had from an earlier exercise to solve a problem later down the road, you will experience the essence of how mathematics develops over time. Throughout this course, we want to illustrate the idea that math is a building where every new concept is constructed on previous topics that sometimes even go back to ancient Greece. This subject is alive and kicking, growing with new ideas and discoveries as well as unsolved problems that give a hard time even to the most experienced people. Even though discrete mathematics works with finite sets of numbers, the subject itself is an infinite art that requires creativity and outside-the-box thinking to deal with the difficult problems that arise. Let's get started.